Okay, so in this video we are going to talk about exponential growth. We're talking about this idea of inflation. So the idea with inflation here is that your current dollar will buy less in the future, and what that means is as time goes by, the cost of things effectively increases. And you've seen that depending on how old you are. I remember when I was young, you could buy a candy bar for 50 cents. Now they're like $1.25 in our vending machines, which kind of blew my mind. So what we're going to do is assume that inflation remains constant at 4% for the next 10 years. And we're going to look at a simple item right now. We're going to look at a pizza that costs $10 right now. So right now at $10, inflation is 4%, so that means the price will increase by 4% every year. So what that means is we're looking at a percent increase. So remember, if we're looking at a percent increase, I want to talk about a growth factor. So in a growth factor, I'm going to take 100% plus my percent increase. That gives me 104%. And then I'm going to convert to a decimal. And then when I convert that to a decimal, I get 1.04. And now this is the growth factor that corresponds to a 4% increase. So this is my growth factor. Okay, so now what we're going to do is look at what happens to this pizza over 10 years. So after 1 year, I'm going to have this pizza was $10. So here's my starting price of $10. Now to figure out what the new price after 1 year is, I'm going to multiply that by the growth factor. And the result of that is, let's see, 10 times 1.04 is $10.40. So the new price is $10.40. So now here's what the exponential growth idea is. After 2 years, so it's going to increase by 4% again. And what I'm going to do is take that new price and multiply that by 1.04. So I'm going to take 1040 and multiply it by 1.04. And so what I'm going to do is just have this original price This is what it was after 1 year. And now, to figure out the next year, I'm going to do that again. I'm going to take that previous price, whoops, scroll that back down, and multiply that by that same growth factor. And what I end up with then is 10. I know 10 times 1.04 was 1040. If I multiply that by 1.04 again, I get 10. I'm going to round that up to 82. So 1082 about. Now after 3 years, I have that original price times my growth factor. That's my price after 1 year. Here's my price after 2 years. And my price after 3 years, I'm just going to add another growth factor. And what I end up with is now 10 times 1.04. And I'm going to do that 3 times. Yeah, so I get 1124. So what's happening here is I'm multiplying by my growth factor once per year. So for example, after 3 years, I have 3 growth factors. So what I can do is say after 4 years, I'm doing this is repeated multiplication. So after 3 years, this is the same as 10. If I multiply by 10.04 3 times, that's the same as multiplying by 1.04 to the power of 3, because this is 3 factors of 1.04, so 3 of my growth factors. And this means now after 5 years, or 7 years, anything, let's do 10 years. After 10 years, I don't have to do this over and over again. I can just say after 10 years it's going to be my starting price, and now, because I'm using one growth factor for every year that goes by, I can just take that growth factor, raise it to the 10th power, and that's going to give me 10 times 1.04 to the power of 10. I end up with 1480. So the idea here is, now if I let my input be t, so let's put that in blue, and my output was cost, I can make a function of t that says cost after t years is the starting price, so that $10 that the pizza costs right now, multiplied by my growth factor, which was 1.04, and I'm going to raise that to the power of t. And so this is called an exponential function. And the big idea here is that my variable is in the exponent. So I'm going to give you a definition here. And this is, in general, an exponential function. Where I have an output, let's call it y, equals a times b, and that's being raised to the power of t. Now, this is, a is my starting value. So in the case of that pizza, that was the $10. B is my growth or decay factor, and we just looked at the growth example. I'm about to do a decay example here. And then T is time, or whatever the input is. It could be other things. We're going to be looking at cases where it is just T. Okay, so I'll post another video in a minute with an exponential decay example.